Okay, thank you, students. In the last class, I was describing you about the graphical method of solving a linear programming problem. Am I correct? And in this class, we are going to talk about the simplex method of solving linear programming problem. Simplex method of solving linear programming problem. The simplex procedure or algorithm or technique, different terminology it is used. Okay, so let us take that particular algorithm about how we can solve the linear programming problem using what is called simplex procedure. Now look at this. The simplex procedure. The simplex procedure consists of all these things. The first step is we have to add slack variable on the left hand side of the constraints, or we have to subtract the surplus variable on the left hand side of the constraints, and that is the first step. From that we can get the standard form. Okay, that is the first step. Okay, now look at this first step I want to show you here. Look at this here. In this particular problem, x1 plus x2 is less than or equal to 1. So we have to add the slack variable to make this equation. So look at this here. We are adding here x1 plus x2 is less than or equal to 1. Therefore, we have to add a surplus variable or slack variable, sorry, with these constraints. Similarly, here less than or equal to comes, then another slack variable we have to add. Hereby, we are getting these equations. The constraints are this: when we add two slack variable with the first constraints, we are getting this, and second constraints we are getting this. This is the first step in simplest algorithm. Okay, now let's come to the second point or second step. Now we have to write the modified form for the constraints as well as the objective function. Modified form, that is the second step. Look at this, how we are making a modified form here. Can you look at this? What is a modified form is? So modified form is nothing but bringing the variable on the one side and the constant on the other side is called a modified form. Take for example x1, x2, x3 or slack variable s1, s2 or surplus variable s1, s2 we are bringing on the one side and the constant on the other side. That's called what we say a modified form, we say. That's what in this case we have here. Now look at this. Now I will bring this down so that you can understand well there. Now look at this. We are bringing all these variables, okay, on this side. Bring all these variables this side. What you will have? This you will have. See here. Bring this side minus 2x1. Bring this side 3x2. Bring this side minus 0s1. And this minus 0s2, that is already there. Similarly here, here we are adding 0 to s1 plus 0 to s2, then we are bringing there. Okay, here x1 is here, x2 is here, S1 is here, but X2 is not there. Therefore, 0 to S1 we are putting plus Z is not there. Therefore, 0 Z we are putting and the constant on the one side. Similarly, here S2 is there, X1 is not there, 0 to S1 we are putting. So 3x1 plus x2 plus 0s1 plus s2 plus 0z, because here z is not there. So variables on the one side, left hand side, and constant on the other side, the right hand side, is called a modified form. That's the next step. Okay. Now, what is the next step is that we are bringing this modified form into a tabular column. The tabular column, we are bringing this modified form into tabular column. Okay, such that in the top we are writing x1, x2, x3, x4 dot 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 s1, s2 dot 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 z and the constant variable and the basic variable. Like that particular column way we are writing there, and that's called what? Tabular form. That comes next. Okay, now look at this. Sorry, please wait, I will bring back the screen now. It is not coming there. Okay, so it is better to minimize so that where it comes, then afterwards we will maximize. Okay, that is best, I think so. Now we will maximize it so that we'll bring down the pages. I will fix according to the need for us. Okay, now look at, yeah, we got it, but not correct. Okay, now look at this. So whether to your screen this is very clear for you or not, I don't know, because your screen is very small, the screen. Okay, now look at this. I told you just before what I say, the modified form into tabular form. Okay, that's what we are going to see now. Now let us take this. Now look at this. Look at this. This is what? This is what modified form. Now what I have done, x1, x2, s1, s2 is that constant basic variable, because these are the variables coming in all the equations. So x1 is coming, x1, x2, s1, s2 is that constant basic variable. So I have written all the variables at the top. Then I am writing the first objective function here, minus 2. Its coefficient I am writing here. Coefficient here is minus 2. Coefficient here is minus 3. Coefficient here is 0. Here coefficient is 0. Here coefficient is 1. Constant is 0. And then here x1 coefficient is 1. x2 coefficient is 1. s1 coefficient is 1. S2 coefficient is 0 and Z coefficient is 0 and 1. Last one, coefficient of this is 3, 1, 0, 1, 0, 4. This is what the next step. Okay, so go back to the next step there. What is the next step in the algorithm is the first simplex table. We say that this is the first simplex table. So what table we saw just before is called the first simplex table. That's what you have to understand. Okay, now next step, test for optimality. Test for optimality. So test for optimality means whether the uh, step have reached the minimization or maximization. Okay, that's called optimality. Whether the steps have been reached optimum, we can check up. That is the next step. So let us take next step here, and we'll see that. This is called test for optimality. Test for optimality is not reached because of negative number in the Z. Look at this particular table. Here, our aim is maximization problem. Let me correct. Now look at the problem here. It is maximization problem. I think it's a maximization problem. But we have here, we have here, what we see here is a negative number coming in the objective function. It should not be the case. It should be a positive number. Then only our maximization will be reached. Okay. So now that's called the test for optimality. After the first simplex table, we have to look for test for optimality. That is whether negative number is there or not. If negative number is there, optimum is not reached. If all are positive, then optimum is reached. That's called what? Next step we say. Next algorithm. You see here, test of optimality. Then minimum replacement ratio. What is a minimum replacement ratio? Now look at this. This is the formula for minimum replacement ratio. Ci by xi. Ci by xi. That is minimum replacement ratio. Now, before that, we have to find out here what is the incoming variable. What is the incoming variable? We have to find out. Incoming variable is the maximum number, negative number. Maximum negative number is the incoming variable, minus 3. Now, what is the outgoing variable? Okay, to find the outgoing variable, what we have to is that we have to find the minimum replacement ratio by using this particular formula. Now, look at this. This is what? Constant. This is what? The variable. So this divided by this divided by this. That's called what? Minimum replacement ratio. We have to find out among 1 divided by 1 and 3 divided by 0. That's called what? Minimum replacement ratio. So here minimum replacement ratio is 1 divided by 1. 4 divided by 1 is sorry, here in this particular table we have to see there 1 divided by 1 and 4 divided by 1. 1 divided by 1, that is 1 divided by 1, 4 divided by 1. The minimum is what? 1 divided by 1. Okay, that's what we have to see here. So after finding the minimum replacement ratio, we can identify which is the incoming variable, which is the outgoing variable. Then pivotal element we have to find out. The intersection of the incoming variable and the outgoing variable is called pivot element. After finding the pivot element, we have to make it 1. We have to make it 1. Then again, we have to go for test for optimality. Again, we have to go for test for optimality. Then from the first step onwards, we have to go again and again till all this particular row must be positive. Okay, if all are positive, this will give you the solution. We have to see all are positive here. If all are positive, then this will give you the solution. Substitute this value in the objective function. will get the answer. This is